Welcome everyone. Welcome back to all the online audience too. So I'd like to thank Dr. Singh to give us insights about how Phenocam or Phenomat can be used to study the ecology of the forest and also help us understand the gaps that already exist in the studies, especially in the calibration or the validation of the data that we have received from the Phenocam. Now I would like to invite Dr. Rajiv Kumar Chaturvedi, our second speaker. There's a bit of change in the schedule, so Dr. Chaturvedi will be presenting now. Dr. Chaturvedi is an associate professor at BITS Pilani, Goa campus. He obtained his PhD in ecology from the Center for Ecological Sciences, Indian IISc, and he has his master's degree in geography from the Delhi School of Economics, Delhi University. Dr. Chaturvedi has been National Environmental Science Fellow at IISc and has contributed to more than 40 peer-reviewed articles and 2 books in the areas related to forestry, environment, and climate change. He's also been lead authors to the Regional Assessment Report by United Nations Environmental Programme and Intergovernmental Panel on Biodiversity and Ecosystem Services. Dr. Chaturvedi is currently the co-chair of the Forest Ecosystem Groups at International Union for Conservation of Nature, and he is also involved in India's National Greenhouse Gas Inventory Program and is listed as the UN expert for GHG inventory in the land use and forestry sector. We welcome Dr. Rajiv, and it's a privilege to have you here.
So thank you very much, Dr. Sufi, and it's a pleasure being here. And I would like to thank DG sir, Dr. CP Singh, and Dr. Suresh, and all the other present people here for the opportunity to speak here. The topic I have got here to share the experiences about one of the Phenocam sites that we are operating as part of the ISRO's IGPP network. So this is this we have set up in Western Ghats in Netravali, and that is what I'm going to share the experience about. But before we go to that specific site, probably a couple of slides talking about the broader picture. So I think Dr. CP Singh has already touched upon it. You can see phenological observations you can do via multiple ways. One of the ways is to do that at ground level, a human observer looking at it, which people have been doing, and which our colleague from EMPRI, Dr. Sharma, has also presented. And of course, based on satellite, also it is possible. But as Dr. CP Singh has said, the satellite-based phenological products needs to be calibrated. And the products that we have right now are not really calibrated well. So we need to improve upon them via ground truthing. The third way of doing that is probably the Phenocam, like phenological cameras, which are overlooking the forest from the top. But today I learned from Dr. CP Singh that we can put something from below as well. And probably we will try that at our site. So this is not only learning experience for you, but for me as well. And probably a combination of the top-based observations and the ground-based observations probably will give us more insights into the phenological activities that are going on in the forest. Now, this is an important slide that this is based on the literature review, which my student, PhD student, Mr. Karun Josh has put together. So the conclusion of this paper that is now under review is that phenocams or phenological cameras that we are talking about in this talk are an efficient, affordable, and reliable near-surface remote sensing alternative and complementary to ground observations. See, ground observations will still be important. They have their own significance. Nothing can replace that. However, this is one of the complementary, which is highly efficient. It is very reliable, and also the cost-wise, it is very affordable. Tool for long-term ground observations in monitoring leaf, flower, and fruit phenology. He has shown that, especially in the 3 parameters, whatever field-based studies are available, they are able to replicate the ground-based observations in a satisfactory manner. We are getting more than 90% or so R value you can see here. This is what a very interesting study he has put together. It is under review right now, which is the basis why we are talking, why we are saying that probably we can go ahead with this new tool, new technology, because this is this tool is able to replicate the ground-based observations in a very satisfactory manner in all the 9 parameters that are being monitored from the ground observations related to leaf, fruit, and flower phenology. And so you can see the same thing, ground-based phenological observations generally record the leaf, bud, etc. Our review suggests that most of these 9 parameters that are generally being recorded on the ground, the Phenocams are able to get them right up to, there will still be 10% error, but up to that kind of accuracy they are able to get. So still it is, however, the problem is that this is another map that he has created for his upcoming paper. You can see that the phenological stations or the phenological monitoring that is happening right currently in the world is mostly concentrated in the developed countries, in geographies like United States of America and Europe. Primarily, it is dominant. And it is also true for ground-based observations. Even in case of ground-based, not only the phenological observations, you name any observations, be it the long-term like inventory plots, for forest monitoring, for various other purposes and objectives. The highest concentration of the ground observations is concentrated in the geographies which are North America, Europe. Also, some of it is available in China and Japan. But you can see the Indian region here. Is it so? This map does not include our network. So prior to our network, this the Phenocam based observations, basically in the Indian context, were quite minimal or mostly absent. So this is why we need to, and see, while we are talking about global change, while we are talking about problems like climate change impact on the forest phenology, as Dr. C.P. Singh has very nicely suggested, how it is an important indicator of the impact of the changing climate on the ecosystems. This impact we need to understand at the global level. We need to create a consistent story about how climate change is happening and how that climate change is translating into effect on the forest ecosystem and other systems which are supported by. But if we have the observations which are concentrated in few geographies, then that globally consistent storytelling is simply not possible. This is all the more important that we fill this very important data gap. Also, Indian condition, like India is a developing country. If we are able to showcase something to the world that, okay, we are able to create a network here, and that network is working well, and we are able to find out affordable ways of doing that, we are able to create our own sort of applications for local forest management, etc. So if we are able to demonstrate that to the world, probably we can make a case to the global south under the G20 presidency of Indian presidency. I think this is a very important, even though the presidency is getting over, I think this is really a very important stage for India to showcase the global south that yes, there is a data gap in the larger global network of monitoring. And here we have, under this ROSE IGBP program, we have been able to set up 15, 20 stations. And now if EMPRI is able to get 2-3 more stations with some of the support that ISRO gives and some of the support that TST has provided, or EMPRI has its own capabilities. So that way, I think we will be able to show that we are able to create our own network in this part of the world, and we can induce others for carrying out such kind of observation network, which is really important. Such kind of data paucity is very stark in the African region. Africa, especially the Central Africa, is also housing tropical forests, which are very, very vulnerable. But you can see the Central African region is completely, there is hardly any observations of the phenological changes that are happening there are available. So this is a very important story that I think it is a bigger story. It is not just what we are doing here, but it is a bigger story. Coming back to India, again, deriving from the work from my PhD student, Mr. Karan Josh. So even if we forget about the Phenocams, so Phenocams prior to the network that ISRO is operating were simply non-existent in India. But we have also looked at the phenological studies that are going on in different parts of the country. We found that maybe 5 to 6 long term, which justifies, for example, as Dr. Singh was saying, there are 37 or so, like 52 or so studies that he has found. But many of them are coming from PhD scholars from different universities. While the scholar has been really active and he has devoted his best of intention as well as work, but his PhD got over in 2-3 years. And then the work was not carried forward. The work got stopped. So in India, you can see that we have very few sites, 5 to 6 sites in the entire country, and we could list only 37 distinct ground-based phenological observations where these kind of studies are happening, and in a very limited forest type. So even from the ground-based phenological observations, there is a distinct data gap that is there in the in our country. Given the diversity, as Dr. CP Singh has said earlier, that we have 16 forest types, distinct forest types in India, we need to cover them. But within the larger 16 different forest types, we have 200 plus sub-forest types, which are equally diverse, which is equally important to at least have some coverage. So I think there is a lot of scope here to improve or increase the number of even the ground-based phenological observations. In this context, since we have proven that the Phenocams are really a cost-effective, because getting manpower to carry out the phenological observations, also ensuring that it is done accurately. If camera is there, you are sure at least something is recording. So I think from all those perspectives, it looks to me that Phenocams may be a really very wonderful thing to adopt in this context. And I'm really very happy that State of Karnataka, under the leadership of EMPRI institution, is taking steps in that direction. And I hope that this will go further, and whatever experiences. So this is how a Phenocam basically looks like. We have, in all the Phenocams, you will see that there is a reference point. So, I think we will be discussing this again also, but I would like to mention that from the Phenocams, we can get a lot of information about the forest health. We can even from the perspective of the day-to-day running of the forest management, and even for creating the forest management plans, what is happening. So a lot of insights can be derived. And that, I think, we have already got data for 1.5 years of monitoring in this particular area of the Western Ghats, that some of the insights I will be sharing with you. So, but just remember, this is how a Phenocam tower. So this is just a tower that is overlooking the tree canopy, and it is looking at the tree canopy at a tangent, and there is a reference point here, so that we exactly know. The reference point is very important. And then associated with it will be the automatic weather station, different parameters, which will be including the soil parameters, which will be monitored. So let me show you the Phenocam tower that we have established in this part of the Western Ghats. So this is the tower that is there, which is, so we have situated the tower on the hilltop. Since we have put the tower on the hilltop, but it is not very far from the tree line. You can see just here the tree line is ending. And on the tree top, there is from this place, this point, the grassland is starting. Yeah. So from this point onward, the grassland is starting. So, and this tower, there is no provision of electricity in this area, and we are committed for using the renewable resources. So we have plenty of solar panels that have been installed. And we have, you can see here, we have the digital camera that is installed here. We have power sensors. We have power sensor. We have solar panels. We have temperature, air temperature that is being measured. We are measuring humidity sensor. We have soil sensors. It is measuring the soil temperature as well as soil moisture also. And we have and then we have a rain gauge. So all these parameters, all the air temperature, humidity, rain, soil temperature, all these parameters which have been specified by ISRO under the Jaya GBP program. So we are doing all the measurements as per the specifications, and so that everyone, all the parties in the group program, they all are measuring the same parameters, using the same sort of protocols and same sort of calibrated equipment, so that it is all comparable across the domain. I think this was a very important concern that Dr. Sharma has raised. Now, we have, apart from this Phenocam tower, we have also taken the liberty, even though that was not under the requirement of the project, but we were quite, I have come from Center for Ecological Sciences. We have long tradition of maintaining, especially my PhD supervisor, Professor Ramasukuma. He is well known for like managing the, so I had the opportunity to go to the plot and learn a lot from there. So I was eager when this opportunity came. So I was told by the experts from ISRO that this tower is fantastic. Whatever you guys are doing is really good. However, if we had some idea about what is going on in the forest, if we had an idea who is that we are monitoring, which are the species that are there, what is the biomass that is there. So basically talking about the ground monitoring of all those things of the forest. So we have taken this challenge up to us, and we have in the field. So this imagery line that you can see here, that is the field view of the camera. And our camera is situated at the hill at a relative higher point, and the camera is overlooking this entire forest here. And this is the total field of view of the camera. Within this field of view of the camera, we have established 1 hectare plot. But since we are talking about a very rough terrain, our terrain is really, we are talking about the Western Ghats. That too, the height is quite 700 meters from the sea level, and we have to every day rise from the almost 15-20 meter to the height. So this place is highly undulating. Finding 1 hectare intact patch for doing that was a challenge, but yes, with great effort, especially by the effort from our students, and they were quite enthusiastic. So it is all their effort actually. We have been able to find this this forest patch here, We have done a theodolite survey of this. We have done the civil engineering survey. And based on that survey, we have notified, like we have demarcated this entire 20 by 20 meter plots. So we have, I think I can show you more about the plot here. Sorry, I will, okay, so this is the plot. I will come to this plot. So this is around 180 meter long and 60 meter width. So we get 320 meter by 20 meter ways here on the width side. And then we have 180 meter long. This is what, but this is still very undulating. Standing there and doing any measurement is really very challenging thing, but still we have been able to do that. We'll come to that. But let me first cover the things one by one. So I will first come to the automatic weather station. What kind of data we have received from that? So I think you are talking about, Dr. Singh was talking about the monthly versus daily data. So this automatic weather station that has been prescribed by ISRO under the IGBP program, which all the partners are using equally. So we are getting this data at every half an hour interval. Even the automatic weather station data is even lesser actually. However, making sense of 10-minute data is very cumbersome process. So we have standardized at half an hour, every half an hour interval, we are getting all the weather parameters, including the temperature, the rainfall, humidity, and all the parameters which we have discussed about. Now, sir, you can see this is how the, and then we are able to create, because we have so many observations. So even in a day also we have 60 or so observations, data points. So we are able to, so we have plenty of data to create these 95% interval classes, etc., and a mean value, and the individual values, they are fluctuating much beyond. So you can see we have been able to create a very nice kind of map, and we have shown that the daily data even in the Western Ghats, the daily mean temperature has crossed more than 28 degrees centigrade. I think this number is quite significant. When I look at the literature, there are papers which have published that once the mean temperature in a forest area crosses 28 or so, probably you need to be careful at that point of time. There may be some risk of forest fire, etc. Now, I would like to draw your attention towards this relative humidity data set that, see, even though there is a huge amount of fluctuations, we have been able to create, now you can see in the Western Ghats, on some of the days, especially in the March this year, the relative humidity, I was not able to believe it in myself that the relative humidity has dropped near to 20% or so, which is very less. And again, there are papers from Mudumalai, which Professor Sukumar has shown with her students that even when the relative humidity goes below 20, like 40% or 30%, in a dry deciduous forest or moist deciduous forest, that may be a cue for forest fire. That maybe you need to be really worried about that. Here, in a semi-evergreen or evergreen forest, it went below 20 degrees or so, which is again, I think all these informations that we are getting, and kindly have a look at the daily max temperature. Again, the temperatures have touched 39 degrees centigrades on some of the days. I'm not saying all the days, but on specific days, which is again very high. So all these numbers, I think this is just 1 year of experience, but all these observations are very important. Side by side, these observations should be seen on the or matched with what is happening in terms of different processes, etc., in the ground. Probably these will be the cues. These sort of observations will help us in creating some sort of understanding at a localized level. Every forest is different. The threshold for getting into a disturbance for every forest may be a bit different, because their internal dynamics, their structure, etc., is different. So the more localized data we have at a very forest range level or so, I think better like forest management plans can be prepared based on that. Even this has a lot of forecasting ability also, because we are getting the data in the real time. as the observation is happening, with the support of a SIM card, the data is coming within, I think, 15 minutes or so into our server. So we are getting the data at such a, in the real time mostly. So, but if we want it, we can have a delay also if there are operational reasons. So it has a lot of forecasting abilities also. What I'm trying to say, sir, if you link these observations with the IMD forecasts, or if you have a better model, so this is where the modeling and the observations should be integrated in order to bring better forest management plans, etc. I think this is just 1 year data. I think as we will grow, as we will go forward, we'll get more and more insights into the dynamics, different dynamics that is happening in the forest, and probably it will help us. This is again, you can see the daily bar values that we have got, and on the left side here, I would draw your attention here that we have recorded the daily. So here we have not plotted like 30 minutes or interval of rainfall, even though we have data for all the things, but we have plotted here the daily rainfall statistics. And you can see on some of the days in the forest, the rainfall has touched 200 mm also, which is really very high. It is like, again, alarm bells, because it might have implications for landslide, etc., which Mr. Maji is very well aware of. So these all informations are extremely important for the forest management. If you are getting these data sets into your mobile in real time, then it is highly useful. So even if we think aside, even if we keep aside the phenological gains, etc., which were even this the AWS based information that is, and all these protocols we have generated as part of the IGB program, and which can be supplied to you, which can be shared. We are very happy to do all the kind of things. And then we have very recently, even though the wind was not part of the protocol, but we are very ambitious. We always wanted to have more and more of the situation, like best of the situation. So we have tried to get we have installed a wind sensor again, and this is the data that we have got about the direction and the speed of the wind from so the wind speed, what we have measured is mostly it is confined to 21 meter, like 21 kilometer per hour or so. But it has, on many occasions, it has gone beyond that as well. So we have complete information on the wind information. So this is about the automatic weather station data. And then now coming to the Phenocam. So I spoke about all the parameters that are coming from here, and rainfall and all that. But this is the Phenocam. This is the camera that we are actually referring to as the Phenocam. So from the Phenocam, we are getting the data in the JPEG format. Actually, I have tried to answer the questions that Dr. Shruti has put to me. So we are the data format. The data format is very simple, JPEG format. These files are not very heavy files. In terms of storage, because ISRO has taken care of all those limitations, because they knew that the observations will be carried out by universities and other institutions, which may not have very sophisticated computers, computing resources, etc. So the data format is JPEG format, and the data interval we are getting every 30 minutes. From 9 to 3 p.m. we are getting data. After that, it is switching, because due to the sun's location, etc., it was decided that it may not be further useful to collect data beyond that. And then the data storage is being stored in two locations. Once the data is being stored in the memory card that is there within the tower itself. So that is like our reservoir of data. And the second, data is being stored on the server. So we have created a dedicated server to store this data, and it is a secured server because we are dealing with this very important data set. And we are getting update, and the server is getting updated every minute. It is refreshing itself automatically. Also, sometimes it so happens if the signal is weak, then some of the portions, then not all the data will be transmitted, some of the data will be transmitted, but some of the data may still be there in the local storage. So in that case, what we do, we go to the field once in a month or 15 days or so, and then we take the entire data set in our pen drive or so, and then bring back and complement. But that happens in case like when the signals are really poor, probably rains are happening, probably some other, like those are situations which everybody will be facing. And data access also we have written here primarily via server. So we have shared the server with our ISRO colleagues. So all of us are able to see the data in the real time. So in terms of analysis, in terms of making decisions on that, if there are any requirements, it is possible to view that in real time. So this is a very interesting system, I think, that has been set up. I think we will further see how the system goes. And now, coming, these are the two images that we are getting every half an hour, and this is the reference point that is put there. So this reference point tells us about the scale and other things. This is very important for us to make sense of the data, what is being seen there. So this is the RGB in the optical, like as Dr. C.P. Singh was saying, from 0.4 micrometer to 2.7 micrometer, and then this is the IR image. So we are getting the images in the two, so in RGB band as well as in IR band as well. And based on these, as a preliminary, see, a lot of analysis can be done. As I have said, people have published papers showing all the 9 parameters which we are mentioning, including leaf, fruit, and other parameters. It is possible to do that. However, we have done, because we are still in the primary stages, we have done a very simple analysis, especially my PhD students have done this. And as Dr. C.P. Singh was showing that indicating chart, in that chart, he was talking about the start of season, end of season, length of season, and such kind of variables, which are globally understood and which is being referred as the phenological parameters. So you can see here that we have been able to create, however, a semi-evergreen patch, which is higher on the evergreen side. So our patch is evergreen, but in the evergreen patch also, I think we are heavy on the evergreen side. We have larger number of trees and species which are of the evergreen variety, lesser number of trees, etc., which are deciduous or leaf shedding. So you see that only few of the trees are shedding the leaves, etc. So all that is being captured here. This is the preliminary data sets that we have been able to create based on the RGB image as well as based on the IR band. And this we will be using to make sense about the start of season, the phenological calendar, etc. We will be using on this. But however, what we feel that probably 1 year of data, it is just 1.5 years of data, probably it is not enough. Probably we need to wait 6 more months, and then with the support and help from ISRO and other colleagues, probably we will be analyzing it, and we will be, our goal will be to look at this data in conjunction with all the other partners of the program. There we have partners, luckily we have partners who are working in the deciduous forest. Now, so when we put this data in the context with the larger group, I think then we will have some very strong insights that will emerge from this analysis. For the assessment of these curves, my students are using this particular package, and for this package is freely available. It is a R-based package. It is freely available. It is not under any like paywall or any other thing, and we have good experience in using this package. And at any point of time, if you are scholars or you require support in that, we will be very happy to provide you support in using this. We have been using this software, and but at the same time, we are facing a lot of challenges in maintaining this tower at the ground, actually, there, because it is in the Western Ghats, which receives plenty of rainfall. It has a lot of disturbances, etc. Going there especially in the raining season, is very difficult. Climbing on the mountain is very difficult. There are challenges. So, like many times due to low battery. See, when the rainy season happens in Western Ghat, it happens, the cloud cover will be there for a month or so. The solar batteries will not charge. So the system will shut down on itself. So then, but if such kind of thing happens, then you get to know automatically. Instantaneously, you get to know that there is some problem that is happening in that regard. Because you stop getting the data, you refresh the data and the data is not, new data is not coming. Then you go to the field. Probably you know the battery will be gone. So you have additional battery, you change the battery. So I think this is very labor intensive, but it is less labor intensive compared to the ground phenological work. So still a lot of hard work remains. A lot of dedication will be required in order to keep the tower functional and keep it maintained while the entire process is going on. Network fluctuations are also an issue, especially in the forested area. In the cities also, sometimes we have call drops, we have network problems, etc. But imagine about the forest areas where the network coverage is very small. But I think all these issues are technology-based issues, and these issues will get better and better in the coming future. Because as newer and newer technologies are emerging, I foresee that in our place, there are some special problems. Our ants are very dangerous. So they are cutting our cable itself. The soil sensor, soil data is a problem with us. So Dr. C.P. Singh is saying that, could you provide me all the soil data? I said, we have huge data gaps in soil because the ants are cutting our cables. So we go and put another cable, and after some time, especially in the dry season, it is having like a lot of problems. And sometimes forest fire also happens. So our cables are melted. All those challenges happens. But I think that is part of the business. In the long term, if we are getting our data 10, 15 days of data gap, that will be there. I think that we can live with. And that is why it is all the more important to have many more like such kind of observations, so that my data gap can be filled from a nearby station, because we may have some correlations between the things. I think this is really important and very complementary to have like mutually beneficial systems. So coming to the now we have completed the AWS data part. We have completed. So this is my experiences, and which we have been able to do only because of the support from Dr. C.P. Singh and Dr. Suresh. So Dr. Suresh has supported us in creating the ground plots. So we have been supported a lot by a lot of researchers from India. I will show you all of them at the end of this presentation who all have contributed in. But yeah, so you can see that this is the drone. We have flown drone also here, and based on drone, we are trying to get the multi-spectral drone images also, which are useful for certain analysis. We are also trying to get the hyperspectral images, and we are trying to see if we can identify species. So all those things we are doing a number of, like we have a number of ambitions to like ambitious objectives which are attached, but we are very young, just 1.5 year old like station there. But see, this is the plot that we have established here, and this is the rainfall, etc., the data set that is there. And this tells you all the plots are, each tree is demarcated. We exactly know where each tree is. In fact, we have got DGPS locations also of each of the stones. So we have marked, so all these are these kind of stones. Each stone has a unique number 5, 2. So you can see 5 in terms of here, 5, 2. So this stone refers to here. So as you go in the plot, you will have clear idea where you are standing. So we have complete, and this all we have learned from Professor Sukumar's team, which they have done at a larger scale in the 50-acre plot in like Mudumulai. So we have, like this is the way we have set up the plot, which has been set. And within the 20 meter by 20 meter plot, we have subplots of 10 meter by 10 meter, so that we have more granularity about the relative location of each of the trees, woody trees. And the protocol that we are following for the ground-based observations is that every 1 centimeter and above tree, we are tagging it. We are tagging the trees. We are making them color, like whichever trees we have measured, and each of the trees we are. So we have found in just 1 hectare, we have found around 5,402 individuals, and 100% of the enumeration has been completed now. It is a big achievement. Given that the terrain is high, we have to go every day and come down, and it's really very difficult. So with the support from Dr. Suresh and other colleagues, I think we have completed the innovation. These are some of the results that we have. We have found very high species diversity in this part of Western Ghats. So we have found more than I think this number has increased now, because we have around 85 to 90 species, distinct species we have found in just 1 hectare plot. And yeah, so dominant species is this one. This is just, so these are some of the distribution of species that we have. Yeah, so this is again now coming to the last slide of my presentation. So this is Dr. C.P. Singh. So I'm very happy to tell you that he spent 1 week, 1 full week in our plot, and they have provided us measurements. I think I have shown some. Okay, I think I don't have some of the slides where the measurements were being done. Yeah, probably I should have them. So these are the equipments that have been used, actually, that we have used in our plot. We of course went much beyond the Phenocam brief. We are getting into the larger questions, a variety of questions. So we have used this machine is called DGPS. It gives a very precise location of the stone blocks that we have found. Even the individual trees can be referenced based on this. We exactly know the location, and we can situate them in the satellite images. So that is the good thing. Our whole plot can be geo-referred. So this is one thing that we have done. Then IT Roorkee team has come. This is Professor Siddharth Khare. He has come from IT Roorkee, and he brought with him the terrestrial lidar with him, which is a very sophisticated equipment. He told us that this is first time that IT Roorkee is doing this for the forest landscape. Prior to this, we have done this for landslides or urban mapping, etc., urban things, but this is first time, and I'm very grateful to his students, his team, who are very efficient in this kind of work. And then we have Dr. Nikhil Lele. He has brought his LICOR. LICOR is an instrument that gives you an idea about the photosynthesis activity that is happening. And we have seen that the CO2 concentration, the ambient atmospheric CO2 concentration, I have noted it was 420 in our plot. So when Dr. C.P. Singh was showing, so that LICOR instrument gives that information as well, what is the ambient CO2 concentration, which is matching very well with what is being reported in Maunadua. So yeah, so we have, with the support from all these colleagues from various institutions who have the best of the knowledge in their domains, including Dr. Suresh also, we are very grateful to him. Yeah, Dr. Suresh is here. So yeah, so with the support and help from all of them, we have been able to establish this plot. We are doing very good work. Our papers are, we have communicated a couple of papers because we are quite new, but we are sure that as we go forward, we will be able to answer some critical questions in this area. And I'm very thankful to all the collaborators, and also to EMPRI and Dr. Sharma for giving me this opportunity to speak here. Thank you. Any questions?
As we are getting large data of Phenocam, there's a RGB image also, and IR image also, and our differentiating and how you analyzing both RGB and IR images that is captured in Phenocam.
Yeah. So the images are not very large. As I said, it is KB images. So we have deliberately tried to, I think it's the ISRO protocol So the images are not very large because we are just capturing a very small area. So the images are not very large, and our simple computers can store them. For a yeah.
Question is how you separate it. So basically there are two different files. For IR, we have the same date name and other thing is IR. Then date and then the time.
Yeah.
And for RGB it is a separate file. So you can identify same date, same time, that thing two different files.
So these things are taken care in the protocol that has been given. And with the simple systems, simple workstations, etc., we will be able to work around with them. So technically, we didn't find much of a problem. As far as the analysis is concerned, I told you about the software in R. That is also freely available. It is not a proprietary software. And we are ready to provide you like learning and training, etc., how to use it. We can show you. And I think it is not very difficult. It is possible to get it very simply.
So in Phenocam, we can only analyze the vegetation, like leaf falling, leaf vegetation to leaf distribution. Can we identify the fruiting, flowering, and everything? What about that?
Yeah, that's what I said in the very, so all the 9 parameters, it is possible. It is possible to do that. Yeah, so that's what I have said. In fact, I have a amla tree near my, and we were able to count the amlas and the fruits of amlas. Like it was the fruits, one fruit will look like this if you zoom the image. So possible, I think. It's not very, yes, some level of information may be lost, but it is possible. It has been shown by the papers which are published using this technology that by 90%, up to 90% accuracy, you can get them right. 10% loss of information will happen. So, yes.
Field is it necessary to go to field and then to observe the what is going on, flowering, fruiting, and that data can be integrated with field Phenocam.
It is all the more important. Actually, see, the Phenocam is just a complementary tool. So still the requirement for field-based observation will still be there. It is a complementary, cheap, but the field-based information has several limitations. Getting the trained manpower, getting the reliability factor, the time constraint. Some months you may not be able to go there. And some months, some person has gone, then other person goes, there are personal differences. So the field data has many issues, but still there are many groups who are so dedicated, they have been able to carry out so far. That is based on their work only, we are able to understand and correlate. Okay, this technology also works in a like relatively okay manner. So this is a complementary tool. Still, there will be a requirement for carrying out the ground work to supplement this and keep so that we keep refining our technology. We keep improving our knowledge level in this area.
Are you using satellite images for comparing the Phenocam data?
Yes, yes. That's the whole point. In fact, when we got the project, the idea, yeah, CP, I think in his presentation, he will touch upon that.
Yeah, the entire idea is in my previous presentation also is to use satellite data, use this Phenocam observations as a calibration source, apart from what we can do on the ground. So going back to the previous questions, like on the ground is important, depends on the objectives. So this only observation of the Phenocam is sufficient for calibrating and validating our satellite-based product. We don't have to go really to the but we are more curious, more objectives are added, like he's trying to set up a DGPM model, point-based, and in fact, requesting him to go beyond and do especially explicit modeling for the DGPM. So these things will require you to visit the field, lay permanent costs, and do much more activities. So satellite is most crucial part we are doing. Even recently, I shared some data to the very high resolution.
Yeah, very high. 3 meters.
Yes. So that also we are trying to analyze. So ultimately, aim is to understand from the satellite what is going to happen in land segment and come out with a physical calendar product of India from our own Indian satellites. That is our ultimate.
See, the problem is that from the Phenocam, you can only get the data for the limited time period, 1 year, 2 years. But if you want to construct a 20-year or 30-year, so that you can make a statement about the climatological change, then you have no other way other than to go to the satellite. So we have to calibrate our satellite data product from ISRO and other places to the extent possible. And the calibration will be taking place by these observations from the Phenocam network.
Hello. Hello. Am I audible, sir?
Yeah, you're audible. Yeah.
This is Kuldesh Kumar from HFRI Shimla, sir. I have a simple question. Are you targeting some of the tree species, or you are taking into consideration all the tree species for phenological observations?
No, I have understood the question. Yeah, this is a very good question actually. So, am I audible to you?
Yes, sir. Yes, sir. We are audible,
Yeah.
sir.
So, from coming to the Phenocam, so the Phenocam is looking at the entire stage. In that, we are getting the phenological changes that are happening in the canopy level for the entire image. But in that image, it is possible to, like for example, in our plot, we have majority of the species that are evergreen. So probably they will not show the kind of changes in the leaf changes that are happening. But there are certain, so we are able to identify some trees also. So we are tracking the tree level as well as plot level. Both is possible via the Phenocam thing. As far as at the same time, we also have the ground-based observations of the phenology, in which, with the help of Dr. Suresh, we have demarcated around 84 trees. All the trees are within the camera, field view of camera. They all are visible from the our Phenocam also. So we are also trying to monitor them from ground as well, so that we can calibrate them. So yes, we are doing targeted tree-based, species-based. Also, it is not possible to monitor all the trees in the forest, because you may not have access to all the trees because the forest is very dense. So sometimes we are looking at the trees which are, especially for the ground observations, which are near to the road or near to the, which has some open canopy. Yeah, so all these things are possible.
Also, the field view of this Phenocam you are talking about maybe considered for the upper canopy, and you may be neglecting for the lower canopy species. That might be the limitations, I guess.
Yeah, in case of Phenocam, that may be one of the issues, because what we are getting the top view of the canopy. So in that context, I was quite interested to apply the method that Dr. C.P. Singh said from below, so that he has highlighted in his first presentation. So that is one of the limitations, of course, that we have in this study. However, what we feel that if we are looking at the woody species, so some species, like some individuals of species X would also grow taller, and a lot of other individuals will be smaller. And then, so we will have a fairly good coverage, a representative sample of that forest type. That is what we are actually going for. So, yeah, I hope I have
Thank you very much.
answered the question.
Thank you very much.
Asking like the phenology based data question, like what's the importance of studying and capturing? Is it significant to capture the community data?
For
No, for Phenocam. Camera.
Picture is because actually nothing is going to change that this morning. I think so still we are taking more pictures, and we said in the morning some places we are capturing from 9:30 to 2:30 I think. So great pictures. So actually the idea is not to capture within the day what happens to the collaboration. Idea is to capture the best picture of the day. So that we because in the and together a lot of
Mr.
forms
And sometimes the bird will be sitting somewhere on the, let's say, point of itself and covering the day. There are a lot of situations which happen. It's better to take at least 5 to 6 pictures and choose one of the best picture of the day, then go ahead and one. That's right. It's not that 30 minutes is for the weather, that can then make it more. Like in alpine area, here we are capturing every 30 seconds. Because we expect that kind of balance like that.
Yes.
How do you treat the outliers with the true events and something that we are
Sometimes what happens like parts and things we're talking about. So there's a cloud. Suddenly your bar is completely. So it makes sense. If that this bar is dropped because there is a cloud, but that is important for the growth of the plant as well. So you are aware that suddenly from yesterday to today the bar is very much down, and you will know that it is because of the presence of the cloud. But again, a similar amount of bar is available to the plant for doing the precipitation. So it's really important to understand what that is. So it's not an outlier, it's an observation.
It's observation.
It's
Everything
observation.
is,
And outlier, I don't think it's an outlier. So you have to really interpret it the way it has to be interpreted.
Hello, sir. There is one more question.
yeah, tell me.
Yeah, sir. You have mentioned in your slides that you are using this LICOR PPS system, portable photosynthetic system, for measuring the primary productivity or net primary productivity. So, are you considering the this upper canopy for making the observations, or you are taking the observation from the lower canopy? And how many observations from single tree? Your representative, you are taking a representative from a tree class or something else? Can you please elaborate?
So you're talking about the LICOR sampling.
Yeah, LICOR portable photosynthetic system.
Yes,
sir.
yes.
Actually,
So,
you are talking about the tree species, no? So
yes,
these
yes.
tree
Yes.
species in the forest are quite huge. You might not reach to upper canopy. So how many observations per tree you are taking, and what is this standard methodology you are following for making observations?
I agree with you. This is LICOR measurements are a bit tricky. So as I said, Olea is like one of the species that we found very dominant. So we have been focusing on that species, but our goal is to cover 20 most dominant species. We have not been able to achieve that goal. Only 5 species we have been able to cover so far. Getting the top canopy with that machine is very difficult. We thought about a lot of permutations, combinations, but it's really difficult.
I think that is also not possible to take readings from upper canopy.
Agree.
Actually, as per the standard methodology, you have to take 4 observations from the 4 directions, and from the below canopy, middle canopy, and above canopy. And in the field, we have observed that we might not be taking observation from middle and upper canopy. We are totally focusing on the below canopy observations. So that might be a huge limitations for our observation may not be accounting for this actual observations in the forest.
Agree. So you have kind of answered the question yourself. So
Yeah,
I agree with you. It is a bit challenging, but still we are doing to some we are doing to do something. We are doing something to further our understanding. So one of the things that we are doing, we are identifying the smaller individuals, the younger individuals, where we can reach and where the sunlight is falling. So we are doing a lot of that kind of work in locating the individuals whom to measure. Because in our case, the challenge is also the topography. In some
yes, sir.
cases, mere standing there is a problem.
Yes, sir.
The Dr. C.P. Singh will say how many times we have slid. It is very so. Like we are doing a lot of effort in identifying the individuals whom to sample. But the straightforward answer to the question is that we have identified the dominant species in the plot. Our goal is to cover 20 species for the LICOR measurement. We want to do that. And we are going to the vantage points. We are doing our level best. to identify the best individual within all the limitations that you have said. We are facing all the limitations, but still we are doing our level best to identify and measure them. Yeah.
Thank you very much, sir.
Thank you for delivering all the basic concepts of understanding how a Phenomet works and your experiences with the technology and the challenges that you've faced. I'm sure it's going to help us a lot in continuing our work. So we have the third speaker, Dr. Suresh Hedges.